podcast where we talk to smart people, but not necessarily done by smart people?
That is an awesome question.
This one goes down probably on one of my top 5.
Hey, I like nutrition. I like to eat food.
This is the coolest thing ever. We're going to do this forever.
I wish I paid more attention in that class.
You know, I'm going to be honest, I don't understand that. As a man, I don't get it.
Welcome to smartpeoplepodcast.com.
Welcome to Smart People Podcast, conversations that satisfy your curious mind. Chris Stemp here. Just got off the phone. Literally just got off, well, Skype, not phone, with our guest this week and said, I'm going straight into the intro. Because what happens when you cut your brain in half? Let's put it that way. Our guest this week is Dr Gazzaniga. And he knows more about the brain than most people on the planet. He spent, 50, 60 years working on split brain research. So when you hear, oh, I'm left-brained or oh, I'm right-brained, he's the guy to ask because he cuts them in half in people that are living and observes what happens. And the results are astounding. I'm just on such a high after talking to him. He's one of the leading researchers in cognitive neuroscience. He's a professor of psychology of UCSB, where he heads the New Sage Center for the Study of the Mind. He's a member of the American Academy of Arts and Sciences, the Institute of Medicine, and the National Academy of Sciences. And his book that we're talking about this week is called Tales from Both Sides of the Brain, A Life in Neuroscience. You have to understand that this guy trained at Caltech, California Institute of Technology, back in the 60s. He worked under Roger Sperry, who went on to win the Nobel Prize. He had people like Richard Feynman, who you might have heard of, just drop into his office and literally ask him about the experiments he was running. Normally, this is where I would cut off the intro and just let you go into it. But for the first time ever on Smart People Podcast, I forgot to hit the record button for a few minutes in. And so let me give you a little bit more background. So when I first started talking to Mike, I asked him, what is this split brain research? So as you know, or probably know, right, we have the left brain and the right brain, and they're connected in the middle between a couple of different things. The major one being the corpus callosum. And back in the day, they thought that a way to treat epilepsy was if you cut them, then the part of the brain that was in charge of these seizures would no longer be connected, and you could limit the number and severity of these seizures. And it actually did work. They don't really do it anymore, as I understand. There's better ways of going around it. But given that, Mike and his team were able to study the effects. And I do ask him, why learn about this? But asking a scientist that, really the way science is done is by taking things that work normally and seeing what happens when you alter them. So if somebody has a stroke and there's a lesion on some part of their brain, as he talks about in the interview, it gives us a chance. If you know what happens when things go wrong, then you better understand how they operate when things are going right. The book outlines, it's really written in a story type manner. He talks about his time at Caltech, which was amazing. He talks about the individual studies that he did with various patients, which we get into a little bit in the interview. The other thing we talked about, these were the only two things you missed out on. Back then, there wasn't this red tape that was up. Scientists really said, here's what I want to work on, and they went and worked on it. So what Mike got to do is he did a lot of his training and his research on monkeys. So he could just get a monkey, clip the corpus callosum, and split the two brains, and then do different tests. Well, what was interesting, he was also in charge, him and his team, were also in charge of training the monkeys. Tell me how fun that sounds. Well, nowadays, there's so many different regulations that this research is really getting backed up due to all of that. And if we could just loosen them a little bit, we would make bigger leaps much more quickly. Sorry, it was only about 5 minutes you missed out on. We jump right into it. So you're going to kind of start right from the idea of the split brain. Going to get into it here. First of all, don't forget about our Amazon banner. Even though we don't talk about it much on the show anymore, it still helps us cover these costs. And also, we really appreciate those of you who leave a comment and a review on iTunes. I know when you're listening to this, you're on the go, so it's not the easiest to do so. But to go back, I read every one. Literally. Actually, recently we got a review from Podcast Virgin, and it was 5 stars. I loved it. So thanks for the kind words. Anyone else, if you enjoy, please head on over there. Let us know. smartpeoplepodcast.com is where you can find us. Feel free to email us. Here it is, your interview with Mike Gazzaniga. Well, let's jump into things about the brain, because obviously you've seen a lot of them. I've seen none of them. It's connected. First of all, how is it connected? I mean, what is it made of? We've all seen the pictures. You have the 2 hemispheres, but how is it connected?
Well, it's connected through the 2 half brains, right? We're talking about here. It's connected through a structure called the corpus callosum. And it's literally a bundle of neurons that connect what are called homotopic points for the most part. So a particular point, say in the temporal lobe of one hemisphere, connects to the sort of identical place in the other hemisphere. And so it's just like a big looping neuron that goes across between the hemispheres, and you could think of it as a updating wire to the 2 half brains. And that runs the length of the brain, where these neurons represent information from one side and basically communicate it to the homotopic point on the other. Now, there's cross wires in there, and there's all little subtleties and everything, but that's the main story. And these are myelinated neurons, and in the human brain, there's about 200 million neurons doing this job. And then there's another smaller little nerve cable beneath the corpus callosum called the anterior commissure, and that also connects the parts of the brain called the temporal lobes, the temporal regions of the brain. So together, those 2 form the split brain surgery. Interestingly, in humans, you only have to cut the corpus callosum to get these split brain effects where one side doesn't know anything about the other side. In the monkey, you have to cut this other little one as well. So it tells you how there's different wiring patterns between the two species. And you can go down, long. There's all these little incidental observations in this storyline that make it even more interesting.
Why is it that the brain would be constructed that way? I mean, if we talk about for evolutionary purposes, and how is it that you can cut it in half and it function, as you mentioned, to at first nobody even knew it mattered. So you could literally cut it in half. I imagine if you cut, your arm, one of the forearm bones or something off, it doesn't work the same way, or it doesn't even work at all. How is that possible, and why would it be set up that way?
Well, it's a complicated picture. Let me try to capture it here. So the first take on the effect of the surgery was that, well, look at here, a surgical disconnection of these 2 hemispheres took one mind. Let's use you as an example. Let's say you're undergoing the surgery, and you think you have one unitary mind, and that's who you are, and you have a narrative about it and all that stuff, right? And now a surgeon comes in and disconnects your hemispheres, and when you wake up from the surgery 12 hours later, you would have 2 minds. What? What's going on here? I mean, after the surgery, if I put an apple in your right hand, which goes to your left speaking hemisphere, you'd say, well, that's an apple. You could hold it out of view, and you'd say, yeah, that's an apple. I put that same apple in your left hand, and before surgery, you would say, well, yeah, that's an apple too. Yeah, the same thing. After surgery, you would say, I don't know what this is. What I don't know, you would say. You would maintain you don't know it. But yet I would notice as the patient was holding the apple that they were holding it and feeling it and orienting it correctly and finding the stem and twisting the stem. And that left hand, right hemisphere knew it was an apple, but it doesn't have a speech center. So it couldn't talk to you about it. And then this simple little bedside test, you would just say, oh my goodness, here are 2 completely different mental systems now. There's one that's talking, the left hemisphere, and telling you all about the world, and this right one is processing all kinds of information, able to do all kinds of things, but just can't talk to you about it. The only way it can show you its knowledge is by letting it point to, options that might be related to the question you're asking. So it could respond non-verbally, but it couldn't respond verbally.
Would it know that it was food?
It would know it was food, in the sense that if you put an apple and you said do something to it, it would put it up to the mouth.
Even though it couldn't say this is an apple.
Say what it is. Right?
Wow. So what is the purpose behind that, do you think? For assuming, we've evolved for millions of years to, procreate, thrive, etc. Why not just have one blob that everything's part of? Or I guess that's what it is. This is when you separate it.
So when you separate it, you see that there's lots of complementary processes going on in the brain. That things are some things are doubly represented, some things are singly represented. And then as you get past this first sort of easy approximation, left brain, right brain kind of thinking, and you start studying these patients carefully in a number of contexts over 50 years, you realize, well, actually, there's lots of local distributed systems that are working, and most of them are working outside of conscious awareness. And therefore, you really shouldn't talk about left brain, right brain, but that we are organized in terms of distributed modules throughout the brain. And then the trick becomes, well, how do they all interact and pool themselves in a way that makes you and me think we all have a unitary conscious experience? That's the trick, trying to figure that out. And I would say 50 years on now, that is the big question for neuroscience in general, and in particular, the split brain is just an example of trying to think about how that all. It offers us, there's a billion experiments now where we try to say, okay, how are they cooperating there? How is information being exchanged? Why is there a sense of a unitary purpose? And what do we learn about how normal brains are organized to carry out the same thing? All that comes out of that. And I go into it in the book and try to explain it to the general reader.
Yeah, and you do a great job at that for the non-neuroscientist. One of the things that really struck me is, we kind of touched on this at the beginning of the interview, but prior to you starting this and really digging in, there's a gentleman, I think, William Van Wagner, is that right?
Van Wagenen.
Van Wagenen. So he did the same thing. He separated the brain, and he observed no changes, which was accepted throughout all of the scientific community. What made you, think, oh, this is worth my time to make sure he's right or to prove him wrong? Because I feel like oftentimes, especially now that so much information is out there and available, people look it up on Google, they say, oh, it's already been done, and don't dig any further. And if that was the case, say in this scenario, we'd be completely wrong.
That's just a wonderful point. There's this great Berkeley physicist, scientist, Louis Alvarez, who used to say, what is it about scientific thinking? Is scientists are these just these nerdy, super curious people, and all that kind of reasoning and caricature of the scientific life. And he says, no. Scientists are people who listen to a story and they say to themselves, I don't think it works that way. That can't be it. And they get off their duff and go test another model. So in that sort of spirit, when you roll the time back here in 1960-61, the evidence that Sperry and his student Myers had accumulated on the cat and monkey was so clear, so strong, that even though there was all this storyline about humans and that it didn't amount to much, there was that can't be true. Something went wrong, right? So let's go try this out. And then the luck part and everything was that in fact the appropriate patient to test this out kind of appears in scientific context where these questions were being examined. So that, obviously you're invigorated. You want to go test it, because if you can absolutely show that either way, it was a winning experience. Yes, the human is different. There's absolutely no effect, just like those guys said 20 years ago. Or no, they must have done something wrong. And with hindsight, you can go back and reread those papers and say, well, they didn't quite do this test right, and they did. You can find an explanation, or they didn't actually cut the entire corpus callosum, or there was too many things they left intact, and so forth. So this is why, this is part of this Caltech thing. Well, okay, so you got to just go do it. Just do it. Let's see what's going on here. And there the story unfolded from there.
Yeah, and one of the great things, you could almost consider it not lucky, but just this is how it was. The reason you were able to do this is because it was a accepted medical procedure. Normally it'd be really hard to cut into somebody's brain just to see what happens. But it had been proven that this helped with epilepsy. So your job was to simply study the effects, right?
Yeah. Oh, yeah. I had nothing to do with the medical rationale and argument, and I think both Sperry and myself made a point of not being part of that at all, because that's just those are totally different criteria and rationales to do this or not. And so that was a total medical decision under the charge of Bogan and his mentor, a guy named Peter Vogel. So, yeah, we're there to say, okay, next guys come in and say, what's the effect of this,
right,
and so forth. So, yeah.
Let's take a minute for our sponsor this week, which is a great free tool that could change your life. Yes, that's free. And our sponsor this week is Future Advisor. I don't know if you guys know this about me, but I hate planning for anything. So I do kind of dread retirement because it's decades away, and I'm scared I'm not going to be in a good position for it, especially with all the hidden fees and unexpected taxes. If you don't know what you're doing, you're not maximizing your investments. Okay, so how do you get a good idea of what your financial strategy is and how you're doing? You guessed it, Future Advisor. Future Advisor's Nobel Prize winning strategy and intuitive financial software ensures you get the most out of your investments so you're able to retire sooner. Okay, first, you go to futureadvisor.com/smartpeople and you sign up for a free account. You're actually given 3 months free premium service, and you'll get a free portfolio analysis. So you put in your different investments or where your money is, how it's doing, and they'll actually grade you on it, literally A through F. Both John and I gave it a try, and it was funny to compare both of ours. I actually did okay in diversification and fee efficiency, but my performance, not where I wanted it to be. So if you have any type of retirement account or investment account, do what I did. Go to futureadvisor.com/smartpeople and get a free portfolio analysis in under 2 minutes. Again, that's futureadvisor.com/smartpeople. Back to the show. How much do you think we still have to learn, but we can't, given that you can't really experiment on humans? I mean, I always, every day, because I love this stuff, I'll read something new that's happened to mice or that we've done to mice or to chimpanzees. And since we share 99% of our DNA, but it takes years, decades, and sometimes never to translate that to humans. Is there an answer to that? Is there a way to bridge that gap and figure it out, given that we can't just cut into brains to see what happens?
Well, sure. There, in the last 20, 30 years, there's been an explosion of new technologies that allow us to tap into normal brains, patients with neurologic disorders, psychiatric disorders, lift electrical signals off them, or with brain imaging, look at underlying metabolic processes. And all of this is done non-invasively. It's just science trying to figure out what's going on by all these cool new methods. So that's fine, and everybody from college sophomores to very ill people participate in that, and it's completely harmless. But still, there's a rich body of information from studying patients who have had natural accidents of stroke, tumors, injury of all kinds, and particular parts of the brain become lesion, and their disorder can be manifest. You just see it, and then you're trying to figure out what that means and what part of the brain was involved, and so it's a rich field for figuring out more and more. In some sense, I lament the we live in our jet age, and everybody is naturally biased to using the new technologies, the fancy brain imaging technologies of all kinds. But you can learn a hell of a lot putting on your white coat and walking into a neurologic ward and studying people who experience some kind of natural lesion.
That's a good point. So, since you have done this for so long, I want to get from the expert, what does it mean to, first of all, what does our left brain do? What does our right brain do? And is there any truth behind I'm more left-brained or I'm more right-brained?
Well, everything has a grain of truth to it. So the long and short of it is that when you have this procedure done, your left brain winds up being the brain that talks, understands language easily, and talks, and does complex thinking. And so anybody who is using their logical processes and speaking about them, people say, well, they're left brain or they're analytical, right? And that's true, but that even in the normal brain, while all those processes are majorly centered in the left hemisphere, in the normal situation, the right hemisphere is contributing in subtle ways. And even after split brain surgery, while it's not contributing directly, there's subtle ways it could still influence that. So you get the left brain story. Then the right brain, the isolated right hemisphere, by and large, doesn't talk. And it has these other capacities of synthesizing information, of making certain kinds of visual motor responses more quickly, seeing illusory perceptual events better than the left, and it has a little grab bag full of tricks too. And so people said, "Oh, well, that's the creative part." Well, that's when the thing goes off the track, and it's not quite right. The right hemisphere has these specialized skills, but that doesn't mean it's the creative part, and the left side is just the articulation of the creative part. That's where the metaphor got strained and sort of breaks down.
Because that's exactly what I was going to ask next is, okay, what's all this talk about? I'm creative because I use this side of my brain. So you're basically saying not really science behind that.
No.
Okay.
There are people who, having said that, of course, there are people who psychological profile, they tend to be more creative, they're more generative, they're more metaphoric, they're more this, they're more that. That's true. I mean, there's other people who, just show them a table of numbers and they're happy. That's true too. So there are processes that align with those that are distributed throughout the brain and requires cooperation between the hemispheres in many cases. So it's just not a sustaining idea. It's like everything else. The first idea, simple, clean, and then as you learn more about it, well, it's a little more complex.
Sure. Yep, absolutely. So given both sides of these brains, the experiments you were doing, one you talk about a lot in the book, the study with WJ and the Tacks. And I found this one so interesting because you said how he would pick up a tack and twirl it. And even though he didn't know what it was, he was laughing to himself. And that, honestly, that was creepy to me. Like, not interesting, but creepy because I'm worried, what does that mean?
Yeah. Well, it was an example of, so he had his surgery and he was exploring a series of objects I had. He was blindfolded, so he couldn't see them, you see. If you're trying to examine the touch sensations, you can't let him look at it because then through vision he can say, oh, well, that's whatever it is, But if he can't see and he's blindfolded and you put into his hand, in this case, it was a little block that had a tack nailed into it. And so he picked up the tack and twirled it. and the other blocks and the other options didn't have this tack in it. So he became very fascinated with this because he could certainly have the sensations of twirling this, and they were going to his right hemisphere. And his right hemisphere, for whatever reasons, found that funny, and he was amusing himself with his dexterity there. And then when I would ask him, well, what's so funny? He said, I don't know. And that's his left hemisphere talking, and his left hemisphere doesn't know. The right hemisphere produced the laughter. Right hemisphere, once it's produced, of course, the left hemisphere is in the same body, it feels the chuckling, feels the emotional state. That is not limited in splits. And so it in a sense, if you pushed him on it, would have to cook up a meaning as to why he was laughing. And that was a finding throughout the whole 50 years of research that we came across.
Really incredible stuff. And you actually mentioned the thing about emotion. What have you learned through this, all of your work with the brain, but also split brain, about emotion and how we process it? Do you know much behind the science of emotion as it relates to the brain?
Well, this kept coming up, of course, because we could set up and produce an emotional response in one hemisphere and then examine how does the other hemisphere deal with it. And the long and the short of it was the other hemisphere always got the tone, the valence of the emotion, but it never got the content, because the content was part of the split brain story. If it was a picture that we showed them that made the hemisphere laugh, that part of the events just didn't transfer over. The other side didn't know anything about the picture or what it was. But if it produced tension or laughter or whatever it is, the body is in the same body, the emotional response, the hormonal response, the subcortical cueing, and all this kind of stuff, those are common to both hemispheres. So it gets the tone, it just doesn't know why.
Wow.
And that gave rise to my former student, Joseph Ledoux, really taking that apart over the last 40, 50 years in neuroscientific terms and building very intricate models about how all that was organized prior to conscious experience. And, he really developed the field of emotional neuroscience that in many ways stemmed from this work we did. So
now I'm really fascinated by that. I might have to talk to your former student. What does that help us understand at all how our thoughts impact our emotions?
It does. It's a whole story, and I know I'll give him a plug. He's got a new book that's coming out called Anxious.
Oh wow, that's amazing. I'm talking to him. That's like already I'm interested.
And he's great. He's a great scientist, a great writer, and a great guy. So, and he has a rock band on the side.
Oh, I love it. Is there any advice, not apart from the science, but using what you know, and especially what you were saying about how I can imagine, right, the right side of or left side, take the side, sees something, knows why it's reacting, and then it kind of goes through the body. The other part of the brain just feels it, so knows something's wrong, but doesn't know why. Is there any way that we can use that knowledge and make ourselves happier? Is there a way to respond better? And I'm just looking for anything that somebody could take away from this and go, I'm going to try this today.
Well, so the last bit of our, not the last bit, but the 25 years into this work, we discovered something that we call the interpreter, something in the left hemisphere that is this thing that keeps trying to make sense out of the behaviors we carry out, the emotions we feel. It builds a story as to why we're experiencing those. And that's a big part of the split brain story. And so to the extent that you are aware intellectually that, there is this thing in our left hemisphere that's constantly trying to interpret why we bought that product or why we feel this way or why our hand went over to the door or why we got up at a party and just decided to leave or what, and then we ask, well, why do we do that? And then we make a story to incorporate it into who we are. That's very powerful, very strong. And if you get really good at being able to abstract out that about how you act, you could say to yourself, well, I'm really feeling strong this way, and I bet it has to do with some emotion I'm feeling. I don't have immediate access to it now, so I'm not going to do this because I don't get it. And I'm just going to go neutral here. That's really thought about thought kind of thing.
Mm-hmm.
And sometimes we're capable of that, but most of the time we just go with the first reaction to the feeling we're feeling and making an interpretation on that and acting accordingly. So if you get what I mean, understanding this can ultimately help modulate how we respond, but it's not, that really takes discipline.
Right.
And otherwise we're just all living our lives and trying to make sense out of our behavior and our feelings.
And now, a word from our sponsor. We've got a lot of really smart listeners out there, and whether you're starting your own business and you're tired of using all these apps all over the place, or you're in an enterprise and you're just sick of SharePoint, we've got the solution for you. This week's episode is brought to you by Igloo. Igloo is an intranet you'll actually like. It's a cloud platform that can help you do your best work, share files, blog updates, coordinate calendars, and manage projects. It's easy to use and it's easy to configure, even for the most non-technical of users. Igloo is built using responsive design, which means that everything you can do at your desk, you can now do on the go on your phone. Whether you're a large enterprise stuck using SharePoint or a fast-growing business overwhelmed by apps, create an intranet that matches your brand's look and feel, simplifies how you work, and is accessible on your phone. Listen up. To try Igloo for free, sign up at igloosoftware.com/smartpeople. That's igloosoftware.com/smartpeople. Thank you, Igloo, for being a supporter of Smart People Podcast.
Sure. Well, there was another aspect I wanted to touch on that I found so fascinating, which was called cueing. Could you explain to the audience what cueing is?
Yeah. This was, as we started testing the patients, we saw ways one hemisphere was trying to direct the other hemisphere, even though it had no direct neural communication because the surgeon had cut them off. So imagine this. Imagine you're tethered to somebody. You are standing there, and your friend comes up and behind you, and we're going to now tape your arms together and your legs together, and we say, okay, now you've got to act as though you're one. And for the first bit of time, you're going to be very awkward and stumble, and well, this is crazy. How can we do this? And within a remarkably short period of time, you will start to cue each other. You would say, wait a minute, no, if I'm going here, you got to go with me. So just let this go, or you exchange information. Well, you lead this time, or you lead this time, and you could survive and function. Well, now imagine all that within the body. Imagine all that within the same body, and you can then see, if you're very clever, how the two sides of the brain can set one up for the other to take advantage of the situation. And this comes out in very simple tests, like reaching for a piece of food in one part of the visual field for another. How does the visual information one side of the brain integrate with motor information from the other? When the brain is cut, well, maybe it cues it through the various tricks and feedback mechanisms. And the answer is to it, yes, that goes on. And then you say, well, maybe this is a big part of brain. Maybe all these separated modules that I'm talking about are cueing each other at a low level, and that's how their information gets exchanged. So there's a whole little theory about it. What to show the reader, and this is a kind of a unique part of the book, which I'm very proud of. I have videos distributed through the 12 or 15 of them, I think, distributed through the years of patients doing these various tasks, where I can sit here and describe it till I'm blue in the face, but the reader gets to just click on this video and see it, and see it for themselves, and it really brings a deeper understanding to what we're talking about here.
Absolutely. Yeah, a lot of this stuff is one of those things where it's tough to grasp just by reading. But one of the things, and I can't remember if this was in the cueing section. I'm a little vague on the details because it was, I think, towards the beginning. But tell me if this rings a bell, where you would ask them a question that, like maybe it was naming something or naming a color, and they would get it wrong initially. So as the word started coming out,
right,
the part of the brain that could hear the word knew it was wrong and corrected it. Was that part of cueing?
Yeah. That's another. It goes on in many, many levels. I was giving the simple visual motor one, but yeah, now let's say we have a patient who only speaks out of the left side, and we're flashing pictures of just simple little light, red and green lights, to either the right hemisphere or the left hemisphere. And we're just asking the patient to name them. Okay? What'd you see? Red, green, green, red, red, green. Okay. How did that actually work? Because if the light went into what we call the right visual field, that only goes to the left hemisphere. And so for the patient to name those accurately, it was easy because it went to the half brain that has the speech. Now, what happens when the red and green lights go to the left visual field, which goes to the disconnected, quiet right hemisphere? Doesn't talk, right? And as the patient got into the test, what would happen was the left hemisphere would take a guess at what the color could have been in the part of the visual field he didn't see. And the right hemisphere would hear the guess, and if the guess was right, nothing happened. If the guess was wrong, the right hemisphere was able to produce a little head shake. And the left brain said, whoa, wait. And this is after they learned to do all this stuff, right? Cooperate. And the left hemisphere notices the head shake and then changes the guess, changes the answer, basically. So bingo, all of a sudden looks like they're naming to both sides of the visual midline. It makes it look like they're not split. It makes it all kinds of things. And then you get on top of it and you realize, oh, well, they're actually cheating here. And here's how they're cheating. They're doing this cross-cueing thing and so forth. And it's about as cool as it gets when you're actually doing it and figuring it all out.
Yeah, that was one of the reasons I loved it, is because it's like, even when you do something so unnatural, like cut this brain that's a pear, cut it in half, it will still use, and there's a million other examples in the book throughout, but it'll still use any capacity it can to get to the right conclusion, solve the problem. And I feel like it's just this almost evolutionary backup, no matter what happens, even if your brain gets cut in half, we'll try and figure out a way to get you to the place you need to. I found that amazing.
The brain's built for us all to make decisions to achieve goals. And in the situations in real life, natural life, and in the laboratory, the subject knows here's the goal the guy wants me to do. I'm going to use everything in my power to make that goal happen. And then it finds out it has deficits and really can't do it directly. And it's, well, how can I get that goal done anyway? And then use all these other alternative methods. And then your job is to figure them out and see if it teaches anything about how the brain works.
Yeah, absolutely. Well, I know that we're running out of time here. I had a couple of questions that we didn't get a chance to get into that I just want to ask really quick. And if you have a short answer, great. And if not, I know you gotta run. But what do you think is next in the field of neuroscience? What are you excited about?
There's so much. First of all, there's just the kind of data and accuracy of the data for which we will use to figure out how the brain ultimately works and produces our mental and conscious lives is getting better and better and better and better, more exact and more exact and more exact. But the picture of something, the sort of the roadmap of all the parts of something is one sort of achievement. The next one is to figure out how we think about how all those parts interact. What kinds of thinking should we bring to that question? And from my perspective, I'm very excited about bringing in control and dynamic systems thinking. So I think in the future we should be thinking about marrying the disciplines of basically engineering and neuroscience. If we want to figure out how all of the intricate parts interact to produce function. And that will require some new training programs where both those skills are taught to the students of tomorrow, not things that are sort of haphazardly picked up as they go along because they'll figure out they may need these new tools. So I think another way of saying that is in 20 years, the kind of answer you will be getting when you interview somebody on brains and behavior will look different than the kinds of answers you get today.
Wow. I look forward to that because hopefully 20 years from now, I'll still be doing that. Well, Mike, I have really enjoyed this. The book, Tales from Both Sides of the Brain, is fantastic. It's detailed without being too dense. It's for the common man as well as for somebody just so interested in this. Is there anywhere else that you kind of put the things you're learning into the world? Anywhere else you would like our interested listeners to visit?
Well, a part of the book, when I started the book, it was just going to be a straight science story without bringing in the personal lives of characters, the institutional differences, and then the fun you have. I wanted to kind of, as I got into it, I realized, this has been a life of fun. It's great. I mean, here I am, 75-year-old, and I can't wait to go to work every morning. That means you're doing something you love to do, but it's been fun. We have a lot of fun. We do other things. We're not isolated. Scientists aren't these isolated weirdos living in the ivory tower. And we do lots of stuff. And I try to tell some of the other stories that has made it fun. And so just so that the young student, coming along, I think they've got to learn that science is actually one of the cool ways to spend your life.
That's true. And this book, you do tell some great stories. So, again, I recommend it to everyone. Mike, thank you again so much for your generous time. And, I can't wait to see what else you figure out about the brain. And if you want to put it in book form, we'd all appreciate it.
Hey, thank you very much.
All right. Have a great day.
Yeah, you too.
All righty. Bye-bye.
Hey there. Welcome back to Smart People Podcast. Hope you guys enjoyed that interview with Mike Gazzaniga. Don't forget, you can pick up his book, Tales from Both Sides of the Brain, A Life in Neuroscience, on Amazon or at your local bookstore. If you do decide to pick it up at Amazon, please head over to smartpeoplepodcast.com/Amazon or click on the Amazon banner at the top of the page at smartpeoplepodcast.com. It'll take you over to Amazon. You make your purchases just as you normally would, but we get a nice little kickback from Amazon at no extra cost to you. If you want to get in contact with the show, Chris and I are all ears, so shoot us an email at smartpeoplepodcast@gmail.com or send us a message on Twitter at smartpeoplepod. One of the easiest ways to support the show is by heading over to iTunes and Stitcher and leaving us a review over there. As Chris mentioned in the intro of the show, we really do read every single one of those reviews out there. So thank you very much if you've taken the time out of your day to leave a review. We've got some awesome stuff planned in the future, so stick around, stay tuned, and we'll see you next week.